right, hello everybody. As Melanie said, my name is Andrew Peters. I'm with Dewberry. And this presentation, it will be about 2D and 3D buildings, I promise. I give a little backstory here, and I'm just excited that you came to join. And one thing I'm going to say throughout this is quality data in is going to be quality data out. I just sat through a presentation by a person from Esri at the Federal Users Conference, and they were, I think, from Ireland. They said, rubbish in, rubbish out. And I was like, yeah, 100%, I agree with that. We need to work on the data up front. So, quick story here on Dewberry. Every Dewberry meeting starts with a safety moment and a cultural moment. Safety moment is there's the door. And if you wanted to see the other Dewberry presentation, it's in Salem 1A right now. Cultural moment is about one of these 5 tenets up at the top of the screen here. Contribution, individualism, perseverance, honesty, passion. They're not just words at Dewberry. We start every meeting, we have a whole talk about something that has to do with one of these. And what I'm going to talk about here is quality and our perseverance to complete the Digital Elevation User's Manual. Dr. Dave Mowney, who I'm actually sitting in his office these days, he's retired, but he worked at Dewberry. We're a company that's rooted in quality data. We started by surveyors in the 50s. We're very interested in accuracy. We're very interested in making sure that the data is the best that it can be, sometimes to the detriment of our schedules, but we give you the best data that's possible, and we try to eke every ounce out of the data. If you're not familiar with Dewberry, I was just telling Melanie here, the closest office is actually in Virginia. It's Danville from here to Winston-Salem, but we have offices in Charlotte and Raleigh. Got my coworker Ryan in the back, who's in our Charlotte office, and just a bunch of surveyors in Raleigh, but they're important too. So, like I said, I promise I'll talk about buildings, but I want to start it off with Connecticut State Historic Preservation Office. We, with our eyes set on quality, went to them and met with them about a project where they wanted to revolutionize their historic preservation system. They had boxes and boxes of data, nationally registered buildings, and they had no way of easily sharing this data across the state. During COVID, we were coming into the office, masked up, unboxing data that was coming from the state, creating for them an entire online database where they can now look at data in a very friendly ArcGIS online kind of environment, and they can look up whether or not one Petticoat Lane has a nationally registered historic building nearby, and they can pull the documents. This is all stuff that they would have had to go to Hartford and work through a bunch of different bureaucracies to get the data. But now Connecticut has this data, and this really, rooted in quality and our attention to the quality, led to us being able to work with the state of Connecticut to develop and bring to bear the statewide Lidar collect and orthoimagery collect in 2023 and 2026. 2026 is still to come. So in the spring of 2026, we'll be flying again, and we'll be flying the same data, tidally coordinated. We'll be flying orthoimagery as quick as we can before the leaves pop, and then we'll be comparing the 2026 and 2023 data. We'll be creating all of the same supplemental products that we created for 2023, comparing them, providing a new level of analysis for a statewide program that kind of hasn't been replicated. I say that standing here in the state of North Carolina, which has a great LIDAR data set. And I just want to say, you guys are on the edge of having immense amounts of data. And the data is there. Maybe you need help exploiting it. Maybe you just need a few suggestions on how to use it or how to download it. Maybe you have a hard drive sitting on a dusty shelf somewhere that's full of LIDAR that you're not sure what to do with. So this presentation from here on out is going to be about how to make that LIDAR data useful. There's a couple really simple examples terrain modeling, floodplain mapping. Then we get into land use planning, and we get into managing your infrastructure. Someone said at one of the earlier presentations, the plenary, about like anything is geography and everything is geography, and anything near something is even more important to geography. And Lidar is just another way of mapping all of those things. And the density of the Lidar here in the state of North Carolina can allow you to do that, and the accuracy of it does so. So a lot of times when I give this presentation, I talk about what are the requirements that you would need to collect data that would allow you to build 2D and 3D buildings. North Carolina has that data. It's being collected right now out on the western region. We've delivered a central area with partners in ESP, Sanborn, and others who collect the data and deliver it. It is there, it is accessible, and it has multiple iterations. So it's really exciting to be in a state, as I think Hope Morgan said, it's like so forward, so out there, and so has so much data available. So let's start to think about visualizing the 3D environment, visualizing that point cloud. A lot of decisions need to be made before you embark upon 2D and 3D buildings. Like decisions about like, what am I trying to do in the end? Like, am I doing land use planning? Am I doing solar radiation studies? So, like, do I care about the pitches of the roof? Do I want to put 3 like skins on the building so people know like this one's brick or this one's veneer, brick veneer? Those decisions have to be made early on, and if you're a contractor like myself, you need to have open, honest conversations with your client about what your data and what the data accuracy can provide, because, and I just want to put the warning out there, if you try to overperform out of a data set, you're going to set yourself up for questions. So one example I always give is a church that has 2 steeples, and you've built this beautiful 3D model that has 1 steeple. And someone sees that, who's not familiar with geospatial data, they start to ask questions about that 3D building, then they start to ask questions about the ground, and then they start to bring into question everything about your data set. So I just want to urge people to take the approach that is most applicable to what your end product is going to be. Really sit down and think about what you're going to do with the LiDAR data set or with the derivative products data down the road. Because I just don't want you to stretch yourself too thin, to stretch the data too thin, and then expose yourself to possible issues down the road. So what I'm showing here is level of detail 0, 1, box buildings, 2, which I call my monopoly buildings, and 3, level of detail 3 is just everything buildings, like everything on the building, pretty much an exact replica. And then in the middle here, I have kind of just a digital elevation model showing kind of how dense your data needs to be. This is the ground, obviously, but quality level 1, quality level 2 in some instances, if you're just going to go for the box buildings, is good enough. But quality level 2 data, 12 points, 8 to 14 points per square meter, that's what you're going to look at if you're going to do LOD2 buildings. But there are 2 options out there, one of which I imagine a lot of you have the ability to go back and sit at your computer and just do. There's a deployment solution that Esri has that step-by-step shows you how to create footprints, how to process those, create 3D buildings from those, and host them onto ArcGIS Online. It is phenomenal. It really allows you to quickly build out maybe a small area and show what's possible from the software. I urge people, again, start small, see how long things take. But all of the steps are laid out. There's downloads that you can do and just have all of the data. Here's some requirements. These slides will be posted, and if you have questions, please just ask me. But Esri's way is a way to deploy this solution in a small area, even on a statewide solution. We at Dewberry, when providing 1.5 million buildings to the state of Connecticut, we actually approached it 2 different ways. We tried the Esri solution. We ended up trying and using TerraSolid And what TerraSolid allows us to do is, one, stay in a software that we're using all the time for Lidar and process big amounts of data quickly. Also, it allowed us to parse out the data into kind of like form buildings, kind of doing all the residential at one point, doing all the industrial at another point. That way you can allow it to say, have different criteria for allowing it to understand like which pitched roofs and things are on the roofs and what you care about. Maybe you don't care about residential buildings that much. You just want to know, two sides of the roof and how it comes together. On an industrial building, maybe you want to be able to count the air conditioning units on it. These things are possible. Maybe you want to be able to see some emergency exits on the side. These things are possible. Both these solutions here, the Esri for building 3D buildings and the TerraSolid one, output 3D buildings from Lidar that has been classified to include a building class, a class 6 normally. Our process, though, has to start back at classifying that point cloud. So I have a document here, PDF, that shows how we classified the buildings using the Esri solution. Again, this is kind of the shallowest entry point for everybody. If you have an LASD, if it's not classified already to buildings class 6, here are some criteria. We had a minimum roof height of 8, a minimum building size of 75 square feet. All of these things are just dials you can turn up and down, and you can pick your size. We then aggregated those points, regularized those points, eliminated interior parts. And what that looks like is, creating the class, then making an aggregate polygon, regularizing it, eliminating those interior parts. That's what builds us our footprints. To build the footprint and to be accurate about your footprint, again, rubbish in, rubbish out is the most important part. I can't stress it enough. Like, your data could be as accurate as humanly possible, but if you have a badly shaped footprint, when the software, no matter which one you choose, wants to extrude the 3D building from an ill-fitted footprint, it warps it up, and you get these Willy Wonka-looking spire buildings, and that's just not good data practice. So really pay attention in the beginning to your footprints, how they're going to look, and I like to say use GIS to do more GIS. Take past information you have, take the parcels, take other footprints that you have, present information like Oak Ridge National Labs, they have a great building data set out there. Intersect it with the building footprints that you create or that you have and see how many intersections there are. Look at current orthoimagery. And then future uses, there's AI, ML models. You can input all of the planning data that a planning department that works with you may have about what they're tearing down or building or putting into place. Like, you could start to do some real cool analysis to understand how the buildings are changing over time. So once you do that, once your GIS data has been GISed as far as you can take it and your footprints are good, that's when you embark upon one of the solutions to go from multi-points to multi-patch. And what that ends up looking like is this is an exact multi-patch of a building in the state of Connecticut. And what it looks like here, as you spin it around a little bit, is it's an exact representation of what the point cloud look like. You can see the modeledness of it. This is not what you want to do analysis on. You need something more standard. So this is why we create 3D buildings. They're more Monopoly-esque. They're easier to do analysis on. And these were kind of one of our first sets of 3D buildings for a pilot area in the state of Connecticut. And we quickly learned that there's, again, dials that you can turn to better understand, the planar surfaces. And quickly you can start to see that if you change those dials, it changes even simple roof structures within a building and a building footprint. You can see here where the orange and the green don't align. Just by saying, take into account 5 more feet of planar surface on a roof line will change your entire roof type. I have another couple examples here of just some LOD2 buildings that have been created. Some of them even have nice, like gymnasium style roofs, that go like a half moon kind of shape over there. We've gotten a lot of air conditioning units on top of the roofs. We have an example here, and you have to go from top to bottom, where you can see we've added a half moon shape here on this building that then allowed the model to better understand that, oh, this is what this is, and it could interpret it better. So this is another example of how changing the 2D footprint underneath of the data then allows the 3D model to extrude a better building. So in wrapping up and in circling back to our original client, the State Historic Preservation Office, by doing this project with the state of Connecticut and getting to know the GIO, the State Historic Preservation Office now has an ability to zoom to any of their nationally registered buildings, some which don't have street view, some which don't have much records at all, and now they have a 3D building and they have a point cloud, and they could even learn new things. As I turn on and off the trees here in this one model, you can actually see in the backyard of this historic building there's actually a cemetery that wasn't mapped, and now it's going to become mapped. So by having this LiDAR data, they've been able to uncover more information, and it's just been an amazing resource for them, and it all started because we provided a quality product up front to that one client. I'm here. I have lots of other slides that show 3D buildings, and I'm here to answer any of your questions if there are any.
What are some of the ideas Dewberry has? I'm sorry.
No, you go ahead.
What are some of the ideas Dewberry has to apply, just to what you've done with Connecticut?
So I'll say that Connecticut is going to be using this for a lot of urban planning. They're interested in new build buildings being plopped into the middle of the model to see how it affects others. They're interested in doing solar radiation. They're interested in getting the Z value off the top of the building to understand what kind of fire equipment to send to an emergency. So they're tying in some of the next gen 911 and addressing stuff and getting some of that Z value information. Now you could say like that Z value information could have been on the 2D footprints, but now they have a 3D model and it's just better and they can see, and we start digital twinning the city. Right behind you.
So if you had like oblique imagery of the same areas, would it be possible to create like building facades for your three-dimensional?
Yeah, so one of the steps within the Esri deployment solution is adding, I think it's called fusing layers or something. We did not embark upon that. It's something that like Dewberry hasn't been interested in doing. It is there though, and it is possible. Oh, sorry, I would start with the simplest building first. I would start with just like a box before I would do like gable roofs and all that kind of stuff.
So North Carolina has on spatial data download the 2D polygons already digitized. If you started with their building footprint polygons, and then you had the classified building points, what tool would you recommend to try to add elevation to that polygon? Like if you just wanted to add an attribute, this building is X feet high.
Yeah.
What tool would you use to try to push those building classified points into your building polygon as, trying to get the number of stories?
So you want to know how high the building is or what the elevation of the top of the building, I guess, because you can grab, what I would do is I would create the building point cloud, I would make it a raster, and I would search within that square for the highest point within my raster, take it, run with it as the value. But you might want to need to do a subtraction from whatever the ground value is to get height of the building itself. I would use an Esri tool just to grab like raster math, really. I would make a DSM, I would make a DEM, subtract the two, and check within that polygon. Yeah, I went to your presentation, it was great.
Have you looked at integrating open source tools into part of this workflow to save possibly some expense?
Short answer, no. Long answer, yes, because with the state of Connecticut, 1.5 million buildings, we could not, so the great thing about Esri, you can use the LAS data set, one data set for all of your points, all of your buildings, and you can start pulling out 3D buildings from that. With TerraSolid, you need to go per LAS file. So we actually had to create an LAS file per building. So we created 1.5 million LAS files that were buffered a little bit, that had a little bit of ground around them so it could understand where the building was being extruded from. One of my other coworkers did use some open source tools when they were creating all those small LAS files and dealing with all that file management. And I could get you that information.
Well, I was thinking, it seems like COPIC format for LAZ would be a perfect format to use as a source data set for that.
I'd be interested to talk. We have to do it again in 2026, so let's get in touch.
Looks like it could be used for vegetation stuff as
So
well.
one of the criteria for the Connecticut data set was low, medium, high vegetation. Mike Baranowski in the back, no longer with Dewberry, but he helped me out a lot with that. And we also actually used a concurrent collective ortho imagery that had near infrared band to kind of give a yes, no, this could be vegetation, which really helped clean up a lot of the fake vegetation on the roads that was basically just cars and vegetation in other areas. Because when we could use that near infrared band information to kind of give it a false positive, it was really helpful. NC State?
Yeah.
Yeah, you got a question though?
The only thing I'm thinking of is, talk just a little bit about like what's next for LiDAR in general. It's like, what's the future of LiDAR?
Yeah, what's next for LiDAR? So my boss, when I first started, he said he knew LiDAR worked when a missile took a left-hand turn in Desert Storm and like went into a building. And he was like, oh, the technology I'm working on works. Gosh, LiDAR has come a long way from that. So topo bathymetry, mapping the streams. Dewberry is highly involved in that. We did a shoreline project in 2007 for the whole, East Coast. I think more stuff in topo bathymetry in like smaller riverine areas. If you saw the crash outside of DCA, they actually used topo bathymetry to identify some of the parts of the airplane underneath the water there, and that was some dirty Potomac River water. So pretty amazing stuff that they're able to do. I see the lasers being able to go further into the water column. I see the point density getting higher. I see, there are people trying to send devices up into space and collect things at a lower, there's people trying to take terrestrial LiDAR around and collect every chair in this room. It's what you want to use it for, right? I think we've got a great solution in fixed wing collects. The USGS program for 3DEP is amazing. Statewide groups like NC and Connecticut that are embarking upon these things themselves are doing a really good service for their citizens. I think coming up and putting this data in front of people like yourselves to hear what you would think about using it for is important. Connecticut's about to have 2 different sets of 3D buildings, and even Esri was like, oh, I don't know how they're going to compare those. And so people don't have the 2 sets yet, and they're having trouble kind of thinking about what the next things and how we're going to compare and what it's useful for, honestly, yeah.
Do you have any experience indoor mapping, and is there value?
So people often ask, what's the value for this outdoor stuff? And what I say to that is, if you're looking at a firm map and you see that you're in the floodplain, okay, I'm in the floodplain. If you're looking at that firm map, but it's been made into a 3D model and you see water lapping up against the side of your house, it's moving. So I think engaging the non-geospatial community with 3D maps is how you're going to get how they're going to get involved and how it's going to move maybe even policy. Now bringing it indoors, I feel like, again, we're kind of exploiting what's indoors to some people like us who might kind of understand mapping and geospatial environments. We're then allowing someone who might be remote from us to experience our worlds the way that we do. I'm not sure what the value is there, but I know people have been wanting to go into a virtual Gap and buy shirts for a long time, and we're getting there. All right, I'm here, and I'm here tomorrow. So find me online or find me here. Thank you.